what's the lifetime of the project? Because the lifetime is key for us to steer them to the right technology to be designing in today so that they can manufacture with confidence for the long term. Or they know that actually this technology is going to be available from now to 2027-ish. There will be a replacement technology that will be form factor equivalent, but there will be a change around that timeline. At least then the customer can actually design products in the knowledge of what's ahead, rather than design a product and then next week find out that actually the 4 gig eMMC has been end of life and they've got to change it to a 32 gig.
Hello everybody and welcome to a latest episode of the Making It Happen podcast from Sims, where we bring on world-class guests, experts in their industry to discuss market trends, technology advancements and industry insight. This week, delighted to be joined by industry veteran, all-round good guy and memory expert, Alistair Jones from Intelligent Memory. Good morning, Alistair.
Good morning to you, Kevin.
How are you?
I'm very good. How are you?
Yeah, no, I'm good, thank you. Bit grey today, but hopefully the conversation will brighten that up for us, which I'm sure it will.
Absolutely.
Good man. So, I guess, Alistair, so you and I meet quite regularly at various different events. Recently, we've hosted and attended and had a stand at the Electronic Design Engineering Show. I know also we've been at the Electronic Component shows and various other in between. And it got me thinking just around some of the conversations we were having with partners and prospects that we were speaking to. There seems to be a real increased demand, or certainly a change over the last 2 years, with more and more partners coming to us with small form factor boards and I say edge connected devices looking to use embedded storage. So moving away from traditional storage of maybe memory cards, but moving more into soldered down DRAM and eMMC as an example. And I just thought maybe if, as it's an area you specialise in, perhaps this is where we could take the conversation as to why we're seeing those trends and what it is that is so appealing about these technologies to the new innovations that are coming through. So perhaps if you could just start, just give us a bit of an overview on the types of embedded storage devices and where you think their significance is in today's landscape.
Yeah, certainly. I mean, effectively, when we're talking about sort of the whole area of the technology, we're really talking about DRAM and managed NAND. That's the way I look at it. You're looking at DRAM for the computational sort of demands of the CPUs.
Yeah.
And then you're really looking at managed NAND for the storage of data. Those are sort of the two key areas. As the drive for data increases, across numerous applications, capacities just get bigger and people want bigger, faster, more faster. That's the really simple way of looking at it. Multi-chip packages have started to come in now in the consumer market. That's where you have a DRAM and a NAND in the same package.
Yeah.
Hasn't really come into the industrial volumes and things yet. It's still very much in that sort of mobile phone, high volume, consumer type market. But I think the thing that people forget as well is that if you look at the semiconductor market generally, memory and storage is 25% plus of the semiconductor spend in the world. So, it's a huge area that tends to get forgotten and pushed to the back because it's more of a commodity. But that's sort of the type of products that we're talking about.
And you touched on it there a little bit. So you kind of said actually consumer was probably the driver rather than industrial initially. Are you seeing this trend coming more into industrial? Are you seeing more and more embedded board manufacturers and designers using for industrial applications these type of technologies?
Absolutely. If you look in the past, people were using a micro SD, for example, because they could get a higher density, or it was more interchangeable, or things. As the quality and all these sort of things has increased, endurance has increased. People are now switching from a micro SD to an eMMC and putting it down on the board because they've got the density, they've got the endurance, all that sort of side of things. So absolutely, it's more and more going into the industrial market.
And what kind of applications are they then? Because I know for our conversations, they seem very varied at the events that we had, from people putting them into systems that are used for data logging versus certainly more IoT connected devices where there's a lot of information being held or stored or performance required at the edge device. Where are you seeing the common use cases for onboard DRAM and onboard eMMC?
You're seeing it everywhere. I mean, if you look at the marketplace generally, and we talk about the sort of consumer end, let's just think about the automotive market for a second.
Yeah.
You sit there and say, okay, we've all seen on the news on delays in car manufacturing and all that sort of stuff because they can't get electronics and all this sort of side. But actually, when you look at it, demand has rocketed of the technology inside a car.
Yeah.
If you look now, you've got from, I don't know, engine management systems, powered and heated seats, through to infotainment systems, gaming, you name it, it's all inside a car. All this requires electronics, and of course, the majority of it requires memory and storage. That's a very simple one in that sort of automotive market. If you look into the sort of standard consumer marketplace, PCs. We're very fortunate to be in the UK. Who doesn't have a PC these days? The drive for PCs is just there. Processors keep moving forward, adding bells and whistles, speed, etc. Next generation, it gets bigger, it gets faster, so on and so on and so on. Drives the memory and storage market. Mobile phones, massive consumer deal. Again, drives the whole bit. And that's a great place where to use an MCP, for example, of, you need the small package, therefore they're trying to bring the DRAM and the NAND into a single package and all that sort of side. Of course, users now just want more on their phone. They want more storage because they've got a million apps. There's an app for everything.
Yeah, exactly right. Yeah.
But when you look at it, that's also then utilizing cloud. Whether you're on I don't know, an iCloud or a OneDrive or whatever, Amazon Cloud, they're all driving cloud. So of course, all of the cloud data storage just grows and grows and grows. And again, as they're building the data centers, they want bigger, they want faster, etc., etc. So all these things carry on through all that sort of side. And then of course you've got the DRAM for all the continued computational stuff that's going on to really drive that market. So it's forever increasing. When you then bring that into industry, the sort of the big guys, the Microns, the Samsungs, etc., they all follow that consumer market. It's huge for them. So they're continually pushing the boundaries and ensuring that it's on the latest technology, the smallest node, so they can produce it. But they're continuing to move through the family of devices. I always use my smartphone as an example. I mean, my iPhone is an iPhone 13. It's 2 years old. It's 2 generations behind.
Yeah.
That's how quickly this market moves. But industrial customers, when you go into the industrial side, they want to design a product now and produce it for the next 7 years, 10 years, whatever the timeline is, depending on their marketplace. So, there's got to be a balance between what the commodity market needs, where the big guys focus, and then what the industrial customers need of that longevity of supply and that sort of side.
So that's quite interesting. So take the trade-off on the consumer technology that is moving at a speed that probably isn't suitable for the industrial markets. And I guess if we use the term industrial, we're talking anything from oil and gas right the way through to sea exploration or wherever it might be. Anything that's in a harsh environment or where perhaps you've got vibration issues or you need power to be more efficient because it's remotely powered or battery powered. So take the speed at which the consumer market's working at and how quickly the major manufacturers and the semiconductors are moving to support the volume technologies. What impact does that have on an industrial market and where do they turn to? Because I know this is an area that you guys specialize in, is that long life cycle support. What does that situation look like? How does that play out in terms of how do you ensure you can keep supplying for 7 years when the rest of the technology is moving on every 2 years?
Yeah, and it's all about supply and demand and all that side within the focus area of the business. I mean, if you look at, let's just take a Micron or a Samsung, as we said, their focus, the majority of their profit is driven from that consumer type market.
Yeah,
That's where the big volumes churning out of. When we get into the industrial customers, and as you say, it's a broad brush term. We're talking about embedded computing, industrial automation, security, test and measurement, medical devices, all these things that are being designed and produced for a long term,
yeah,
rather than replaced every 6 months or 12 months, whatever it is. Um, you know, then you need that stability of people saying, right, we will focus on this area, and I call it the legacy products up to sort of the modern day technology. And
yeah,
to put that into perspective in DRAM language, you're talking about the consumers pushing now into DDR5, LPDDR5, and beyond, into HBM, graphics memory, all that sort of side. But we're still producing the original SDRAMs, DDR, DDR1, DDR2, sorry, DDR3, DDR4, and industrial customers are still heavily designing with DDR3, DDR4, LPDDR4, LPDDR4X. These sort of technologies, and then they need to produce that.
yeah.
And of course, that's about ensuring that the fab space is available, that the wafer starts are there, that the right agreements are in place for the long term. And that's really what IM is about, is ensuring that longevity of supply for those industrial customers, which is where our focus is there for the long term.
The interesting point. So you mentioned they're still using SDRAM. So that technology in itself is very old, right? So it's been around for a long time. Why are these customers still using this technology? What's the reason that they still need support for these type of technologies that perhaps the consumer world has moved past?
It's an interesting one. Some of the older processors are still there. They had designs that are still going and in production. People are still designing them in because they don't need that speed, the bandwidth, all that sort of side, or they're still using an older processor for simple tasks. So people are still designing it in. But what also happens, and eMMC is a great example of it today, is eMMCs were available from the big guys in 2, 4, 8, 16 gig devices.
Yeah,
Now their market has moved to 32 gig, so they're end of lifing all the smaller parts and trying to push everybody to the 32 gig. Well, customers are still needing 2 gig, 4 gig, so a 32 gig is just overkill for them. Yes, there are. The price of a 32 gig has come down towards that area, but it's still a waste, if you like, of available storage there within a device. Just because I need 2 gig, I have to use a 32 gig. So again, we've looked at doing 4, 8, 16, 32, 128, 256 for the long term. So there's a long-term roadmap for people. Because of course, every time somebody in the industrial world has to change the device, they have to requalify it. That's engineering time. I don't know what the exact numbers are, but in engineering time and testing and all that lot, you're probably talking $25,000.
and that's without the qualifications that they might have to go through to actually reapprove and retest and requalify as well. Which, when you talk about, I guess, aerospace and defence or medical or transportation industries, there's some pretty excessive test requirements from that side and certifications required, and they can be quite long processes as well. I mean, you'd be looking at anywhere from 6 months to a year to go through that at quite an expense. So, okay, that makes sense. So then, I was quite interested. So a lot of the conversations I had, certainly at EDS, people historically were using micro SD cards or SD cards because of the small footprint. in their devices, but they certainly were very interested and were exploring the use of eMMC and flash technologies that were soldered down. What do you put that down to? Because my take on it was vibration being a big part, because obviously it's a removable device that probably wasn't designed or isn't designed to be on a board in an area where actually there are vibration concerns. And I know obviously there are issues around pins as well with micro SD and SD in environments where they move around. Are there any other benefits outside of vibration as to why you think these companies are looking to move more into eMMC away from SD or micro SD?
I think you've nailed the sort of one of the key drivers. The other one, really, if you think about it, a micro SD that you can take out, change in some technology in some areas has an advantage. In other areas, somebody's just walked off with the micro SD card. What's happened?
Yeah,
Where's
yeah.
it gone? Can't use the system because the card isn't there, or all those sort of things. So you've almost got that sort of security element as well, of at least you know everything's there. The densities have increased on the MMCs, and the reliability and all that sort of side. So again, people can put it down in confidence and know that they can upgrade their firmware and all those sort of things. Because again, part of it was people were using that sort of interchangeable micro SD card so they could change things. Well, you can do that on board now.
At the board level,
So
yeah.
people stay with it at board level. So people can stick with an eMMC soldered down. There's our unit, produced, solid, quality's there, done.
Yeah, no, that makes sense. From an adoption point of view, I guess it's easier if you're a board level designer or an engineer. It's much easier to build your system and to build the firmware around something that you know is going to be soldered down on board, accessible, rather than, as you say, something that potentially moving forwards isn't going to be reliable because it could, as I say, come loose, or you have to glue it down, or somebody can walk off with it. At least then you know it's all on there and you can do your design. Are there any benefits around performance and efficiency? Because I guess power must be an improvement as well.
I haven't checked the numbers, but I'm pretty convinced that there will be a power advantage. There's certainly a manufacturing advantage in terms of the process flow and all that sort of side of things. Again, if you think of an SD card, that's got to go into an SD card holder. All these sort of things. So the engineer's having to put a connector down,
Yeah,
to then plug something in rather than just put the BGA straight down.
no, that makes sense. So that's good. So which applications are you seeing adopting eMMC and DRAM? So what specific type of products are you seeing more requests for?
It really is across the board as we see it. We're seeing a lot in medical. We're seeing an awful lot in embedded computing, all that sort of side. POS terminals. It's everywhere. The list could go on for hours and hours. We haven't really spoken about IoT, for example. I mean,
Yeah,
IoT is one of the big buzzwords that's been around for a while, and then IoT2 and all these sort of things. People want that connected world, whether that's in industrial applications or consumer applications. It's all that connected devices. Those connected devices are then communicating. The moment they're communicating, they're storing data. Data is still king. So there's storage, there's computational stuff. We then got the whole sort of AI applications starting and all those sort of things, and that just drives a massive amount of storage and data.
and what do you think the future for this technology is? Do you think this is a growing market in terms of the embedded storage side? Do you think we're going to continue to see more soldered down BGA technologies being adopted, or do you think this is just a short term move? Where do you see it going?
Um, if I look at this at the sort of the big level, the global DRAM market today is something like $70+ billion, something like that. That will double between now and 2027.
Yeah,
So we're talking 5 years. It's going to double. 144 billion is the latest forecast number I saw for 2027. So that's a doubling. That's double-digit growth year on year on year on year, and I don't see it stopping. There is the demand there to drive that. If you look in servers, for example, the predicted growth rate is something like 17%. If you look at enterprise SSDs, that's up at 14, 15%. These things are going to continue to drive. This will continue into the sort of industrial market as more and more people regard data as king. So there's more storage. They want to do things faster, so the processes get faster. So they need quicker computational calculations and things. So the DRAM gets faster or bigger, or so on and so on. So it absolutely continues to go through. If you look at sort of the next 5-10 years, then there's a huge amount to go. AI acceleration is just crazy.
And do you see this at board level though? So I guess that we understand that in the enterprise environment, obviously enterprise SSDs, there's going to be more requirement for storage. But are you seeing this at board level as well? So you think the future of the BGA, the soldered down flash and DRAM continues to grow at the same rates?
Yes, absolutely. It's absolutely going that way. The more people can put down on the board, the better. That's how people are perceiving it.
And what advantages does that bring? So I know we've kind of touched on a few things, but I'm just trying to understand what's the perfect environment for soldered down. I know embedded computing is clearly one, but if you're an engineer or a designer and you have an option between using physical modules that you can plug into a board versus soldered down, I'm just trying to understand what advantages that brings to them around either processing power or latency or performance. Is it much of the much? Is it the same? And actually, it's probably more about the physical form factor and the size and weight, or are there technology benefits?
I don't think there are any dramatic technology benefits. Obviously, if you're going into modules, you can increase the densities, you can be more flexible. PC is a great example of that. And if somebody's doing embedded computing and things and they want that scalability of memory module, then you have to go through that sort of module size to be able to do the upgrade. The disadvantage then of having it on the board is that the board is fixed. It's that's the density you've got. You can't then have that upgrade path to do that. But I think in terms of on the board, there are some, if you like, quality advantages because the board soldered, it's gone through test, etc. It's not that the module's been put in slightly crooked or whatever. So you've got that sort of it works, the quality's done. You will have some latency as you're going through a connector and things like that. But I think in the big scheme, it's down to the customer's actual requirement for their project.
Yeah.
What are they actually trying to achieve? And that's going to be a big driver for them on which is the right route.
And I guess actually that probably echoes a lot of the conversations we've had around EDS, where it really is size and weight and power that seem to be the drivers, because most of the applications we're talking about are getting smaller and smaller, and there's actually a limited amount of space on the boards or within the application to keep stacking memory storage modules. So they're really looking to make these as small as possible, but as efficient from a power perspective.
Yeah, correct. And that's absolutely where it's going. And that's where, of course, the sort of later technologies come into their own, because if you compare a DDR3 memory to today's DDR5s, you've got a load more of the computational stuff. You've got it faster. You've got it in a smaller package, lower power, etc., etc. So it's, again, as the technology moves forward, the sort of densities and things that people were looking at the modules for are now available in an off-the-shelf BGA package.
Yeah, no, that makes sense. That's very clear. So you touched earlier on the semiconductors, so the likes of Micron and Samsung were a couple of the names you used that provide this type of technology around eMMC or for soldered down DRAM. I guess now for everybody listening, what are the advantages of using an intelligent memory? So you touched on your longevity of supply, but how are you different to those businesses, and where do you look to support where perhaps they don't?
I think as you say, we touched on longevity, and that is a key part. If you're looking at the industrial customers, as we said, they're looking for people that will partner with them for the long term, give them that long-term supply, obviously with the right quality and all that sort of standard stuff that you'd expect. I think the big difference is our focus is the industrial market.
Yeah.
That's where we do all our business. The Samsungs, the Microns, the Hynix, etc., are driven by that commodity market. So they become interested in the industrial market in many ways when they're not selling enough into the commodity market, and therefore they move to the industrial market and service more there. Their technology roadmaps are driven by that whole commodity area. So, of course, in the commodity area is where they make all their profit because they're in the latest and greatest technologies. So that's what they chase after. What then happens is in the sort of the more legacy products, that they continue to die shrink down and things like that to a point, and then they stop and they continue to just manufacture that to a set amount per year because they can only do X amount in their legacy fab. While they're doing all those die shrinks, industrial customers have to reapprove the latest die revision. So we stay with a stable die over a long-term period to really give the customer that longevity of supply. What we want industrial customers to be able to do is to design in the parts today and have confidence that for the lifetime of their product, they can continue to buy it with minimal or no die shrinks.
And how do you manage that? And how do you manage that process then? So I know there are a number of services that you offer to support that, and certainly working with distribution as well, but such as call-off, scheduling, project design, registration. There's a number of services around that area that I know you offer. Perhaps just elaborate on those a little bit.
That's absolutely fine. So there's various points of this when you're looking at the longevity. Obviously, our supply chain and having control over the supply chain and the die revisions and all that side is key, because that enables the parts to be manufactured for the long term. So we have those all in place with the supply chains that we enter into. When you talk about the distribution marketplace, so again, we focus on going to market via the likes of yourselves, the distribution channel, and that brings in the whole buffer inventories, the ability to then schedule, reschedule, all that side. But of course, it also gives us the focus and the knowledge of what customers are doing in terms of their project, which is why we do our sort of project registration. So we understand the customer's project need, and as part of that, what their long-term need for that project is. So, one of the things that I'm always asking you guys as an example is, great, there's a socket available there. What's the lifetime of the project?
Yeah.
Because the lifetime is key for us to steer them to the right technology to be designing in today so that they can manufacture with confidence for the long term, or they know that actually this technology is going to be available from now to 2027-ish. There will be a replacement technology that will be form factor equivalent, but there will be a change around that timeline. At least then the customer can actually design products in the knowledge of what's ahead, rather than design a product and then next week find out that actually the 4 gig eMMC has been end of life and they've got to change it to a 32 gig. So that's the kind of thing that we focus on, to really give people that ability to design and produce with confidence for the long term.
And removing, I guess, the cost and wastage from that process to make it as efficient as possible, so that they do something once, they do it right, and they do it for the longest time possible.
Exactly. I always sort of describe it when the big boys really want to bring the price down, they can. Yeah, of course. When they don't want to bring the price down, they don't. It's at a higher level. We try and be that stable partner through all of this, so that we try and give a stable pricing model for as long as possible, to really, again, give the customer that confidence over the longevity of their product. Yeah, engineers don't want to be designing in a part today that's $2, that next week is $8, and then is back to $1, and then is back up to $6, and the lead time's gone from 4 weeks to 52 weeks back to 8 weeks. It confuses people. It creates a big stir in the market. And the memory and storage market is a cyclical market. It goes up and down. The price levels go up and down. I know you spoke the other week with Marco, and Marco was talking about the shareholder value for Samsung and Micron, and the weak demand versus higher demand, and the whole curve of where we go with pricing curves and all that sort of side of things. We're coming out of a weak demand, low price market. We're going back into a high demand, higher price market over the coming, call it 6, 12 months, something of that sort of order. It's no real surprise in memory and storage. As I say, you can almost plot these on a graph over time of sort of every 4 years it reappears, and it sort of goes up and down through that cycle. So again, we just try and be that stable partner through this. But because our focus is on those industrial customers, then of course our yield goes to industrial customers.
Yeah.
Whereas if you're focusing on consumer commodity products, and you've got the yield, guess what? You're pushing it out to where that big demand volume is to go and drive that, which leaves the smaller customers with no inventory.
Well, and actually, there's two interesting points there. So, firstly, I think in highlighting some of the advantages that intelligent memory bring to market versus the semiconductors, I guess really for these customers, there are no barriers to entry in terms of volume. So actually, for you guys, because of the way that you work and because of your focus on industrial, if you have a partner or a design engineer that is looking at maybe working with 1,000 systems or 2,000 systems or 5,000 systems, you will still support that, and you'll support it in the same way that you would for somebody that wants 20,000 systems. Where I guess the semiconductors are probably interested in 100,000 systems plus, and even that point driven by the consumer demands, depending on where it goes. So that was one interesting point that I thought was worth mentioning. The second, you touched on it, and I know we've covered a lot as a business and with partners, the memory market and the volatility of it around supply and demand. So I don't really want to go over that too much, but perhaps what is interesting is what's your advice for those that are already designing with embedded eMMC DRAM or considering it within their design in terms of how they should be looking to operate with a business such as yourself to manage what is going to be a very uncertain time around supply and price over the next 12 months?
It's a great question. And if you look at the customers that are out there, and again, let's just focus on DRAM and eMMC as a quick example, board down products. If customers have designed it in from another manufacturer, then I would absolutely advise to at least qualify IM on the board, so that it's on the AVL. They might be fine with their supply today, but let's prepare for tomorrow. Let's get the qualification done now, rather than when their production line stops, suddenly go into panic and then have to wait for qualification, and that all carries a cost with it as it moves through. So qualifying now. So I don't know, a DDR3 2 or 4 gig DRAM or a 8 gig eMMC, for example. Plug the IM variant in. It's all JEDEC standard. So again, it's in theory plug and play, but we always say just do the test to be 100% certain. But 99.999% of the time it's fine. So do that first. Secondly is the more they can forecast, and I know customers hate the word of forecast, but the more we can forecast, even at the very high level, that says, we know we're going to make 5,000 to 7,000 boards next year. Right? It gives us a lot more information than we're just going to make some boards next year. Right? We know the sort of amount of supply chain we need in place to be able to service that.
So take that.
Again, I would just highlight, when they get a long lead time on something, if somebody comes back and says, a 4 gig DDR3 is now at 26 weeks lead time, come and speak to us, because probably we're not going to be at 26-week lead time.
Makes sense.
People sort of take it as, well, the big boys have told us it's 26 weeks, so it must be 26 weeks. So they suffer for 26 weeks waiting when they could have been producing.
No, that makes sense. So from your perspective then, there's 3 main areas, which were take the time now, appreciating that your engineering resource is likely to be, engineers don't have a lot of time. They're always working on projects, but actually by taking the time now to design in, have a second source potentially, or speaking with yourself around the original source and working on forecasts is a way to save them future time. So perhaps it is worth spending the time now on that. And then secondly, around forecasting, it's not necessarily a commitment. So it's not a case of, look, you're committing to taking it. It just helps you aggregate where you believe demand is, where you're going to need to make the yield, and will help inform decisions around your stock holding or inventory or your production runs, so that actually, if that does materialize, you're prepared for it, and actually will support those customers that have provided that information. Because guess what? When it all goes short, everybody's going to want it, right? So those customers that are partnering with you in that way are most likely to get supported.
100% agree. And you used a key word in there, and that's really how we, along with yourselves, focus on this. This isn't a customer, distributor, manufacturer relationship. We partner and say, okay, let's understand the project in detail. Let's understand the potential demand, forecasted demand, what you can commit to, what you can't commit to. But we very much see it as a partnership. And therefore, when things do get tough and it does get extended on lead times, it's those partnerships that really hold through, because we will ensure that our partners can continue to produce.
Perfect, great. And on the testing and qualification, I'm aware, because we work with you, we know that you also offer services around samples, support, designing, configuration. So all of that's available. So the advice is, anybody interested or anybody considering their designs or concerned about where the market might go, the best thing is probably to, via ourselves, drop in a message, and we can support with samples, we can support with technical engineering resource, anything that they may need to provide an equivalent.
Absolutely correct. 100% agree.
And other than an email, phone, where's the other place they may find you? I assume if anyone's interested in golf, they might find you on the golf course as well, where I'm sure you'd be very happy to have a conversation.
Never an issue to have a conversation on a golf course. I'm more than happy to let you know that one.
Not so much in winter.
Can't say it's always particularly good, but I will try.
Good man. Well, Alistair, thank you very much for your time. I think we've covered that pretty exclusively, and you certainly brightened up what is a grey day. So thank you. Appreciate your time.
Thanks very much for your time, Kevin.
Cheers. Take care.